All right. So this is vocabulary review. Let me read through these for you. A strong attraction between a hydrogen atom that is covalently bonded and a very electronegative atom. So electronegative atom means that it wants to grab electrons, um, and covalently bonded. So right here is this stuff. So these bonds right here, if you see these lines, that's a single bond. And when you see those lines, that's a covalent molecule. Covalent. This is a double bond. But these dotted lines, you won't see those in the vocabulary. It's the bond between one hydrogen here and this OH over here. Same way with this hydrogen and this OH. Okay, so the hydrogen has to have an OH on it. Here you see it's not, if you were to see a picture, it's not bonded to an OH. So there is some thing here. So intermolecular, that means between molecules. Between molecules. So here is a molecule. Here is a molecule. Here, all bonded with those lines, and here's another molecule there. So this is kind of it's an intermolecular attraction between the OH, this OH here, and this H, this O over here. Right, so this is called a hydrogen bond. O got away. Hydrogen bond. Special kind of bond. There you go, hydrogen bond. Next one. An electrostatic attraction force between negatively charged valence electrons and the positively charged metal ions. So here's the key in this one. It says metal ions. So these are all positive charged ions. And here are all the electrons of the outer shell electrons. That's what valence is. And they're able to move where they want to. All right, so electrostatic means that there's a positive and negative attraction between these. You want to hold them together, but the electrons can move about. It doesn't matter which metal ion. It can move down there, it can move over there. So this is called a metallic bond. Yep, metallic bond. So a pair share 6 or 3 pairs. So 3 pairs, like 3 pairs of shoes. So if I have a pair of shoes, comes with another shoe, right? I can draw that together. So a pair of shoes, so 6 electrons in pairs. So if we pair them up, we got 3 pairs. And this is called triple bonds. Triple bonds. Sharing 4 electrons or 2 pairs. So think about your 2 pairs. So if you have 2 electrons, 4 electrons, and we split them up into pairs of 2. So we have so this is going to be a double bond. Cursive writing there. Two electrons, so just 2 electrons. Like your pair of socks, right? Or, whatever my sock looks like. So that's a single bond. Not very good at drawing in that. All right, so single 2 electrons sharing one pair, 4 electrons, 2 pairs. That's your double. So double, 4 electrons, 2 shares, 2 pairs. Triple, 6 electrons, 3 pairs, 2 electrons, 1 pair. So this is for covalent bonds. So this is all these single, triple, and double bonds are covalently bonded. C-O-V-A-L-E-N-T, covalent. Not ionic, where this is the sharing. So electron transferred over is ionic. So this is a non-example. All right, electrons sharing between nonmetal and nonmetal, so 2 nonmetals. So here's the X from the hydrogen is an electron, and the dot is, so this X, this plus, and this dot tells you this is hydrogen has 1 to share, but oxygen wants total of 8. It has 1, 2, 3, it has 6. So that's why we're sharing there. So this is covalent. It's a covalent bond. And you can see it's between the atoms in the molecule, not outside of it, not to another pair. Yep, covalent bond. All right, shows the number of and types of atoms in the smallest representative unit of. So this, all right, is the smallest molecule of sugar that there is. It's pretty big though. It has 12 carbon atoms, 22 hydrogen, and 11 oxygen. That's what sugar is made of, and this is a ball and stick figure. Ball and stick. And we could have written it like this, just like we could write 2/4 is really 1/2, but we could double everything. But one molecule, the smallest portion of one molecule, has the smallest number of smallest number of atoms. So 12, 22, and 11, not 24, 44, and 22. This is a chemical formula. Okay. Electrostatic bonds of unlike charges, so a metal and a nonmetal. So metal and nonmetal. Cations, remember metals are cations. Nonmetals are anions. They are ions. They have a charge to them. So this is an ionic. Clear that up. Ionic bond. And then the strong attraction between molecules, like the hydrogen bond, this just talks about, in general, everything. That what this is a molecule, and this is another molecule. These are the bonds inside the compound. So the outside are called intermolecular. Between the molecules. Bonding, intermolecular between molecules. All right, so we're done there. Thank you, ladies and gentlemen, for your cooperation.